Well. There's another question that I want us to trash. And if you look at the question on the board, you know that it's coming from thermal chemistry, what I regard as thermal chemistry. Now, the question is very, very easy. And again, if it's your first time of coming across my video, my name is Mosjaro. And of course, if you are watching on YouTube, please do well to subscribe and of course, do well to share and place a comment so that other persons get to see these videos and other videos like this. Of course, if you are watching on Facebook, do well to follow me on Facebook, likewise on Instagram, likewise on TikTok. Quickly, let's fall into this question. They said 0.9 grams of ethanol raise the temperature. Now, while looking at our questions, we make sure that we analyze each of the points and each of the terms that they use in this particular question. Now, they are saying 0.9 grams of ethanol raised the temperature of what? Of 100 grams of water from 298 Kelvin to 312 Kelvin when burned completely. Now, they said the temperature changed when they burn ethanol in what 100 grams of water, and the temperature change. Look at the temperature change. It said, what is the heat of combustion of ethanol? You know what it means? It means that what's the heat of combustion of 1 mole of ethanol? But first of all, we need to know the amount of heat of combustion of 0.92 grams of ethanol. Now, how are we going to do that? Now, you come here and say that the heat generated by this guy, number of moles of this guy. First of all, convert this guy to number of moles. You know that number of moles is equals to what? Mass over molar mass. Quite all right. Good. Now you know fully well that the mass here is 0.92 grams over. Now the molar mass of ethanol. Now what's the molar mass of ethanol? First of all, ethanol is what? CH3 CH2O what? H. Or you can simply say, okay, you can go like this, or you can simply say C2H5 OH. Now this is ethanol, and ethanol is also called what? Grain alcohol. So what do you do here? 12, that is what? 24 plus what? Plus 5, that is 29, that is plus 1, that is 30 plus oxygen. So will now be 30 plus 16, that will give me what? 46. So the molar mass of this guy is what? 46. So now say 46 is equals to, now if you divide this guy, what are you going to have? Now quickly, let me check my calculator, make it for fast. So we'll now say what? 0.92 divided by what? Divided by 46, and you are going to be having what? 0.02. Now this is the mole of what? Of ethanol that produced this heat change. Now first of all, what's the heat of combustion that these two moles was able to generate? So you will now say heat is equals to what? Mass times specific heat of water times the temperature what? Times the temperature change. So it will not be what? What's the mass of the water? It's 100. Remember, it was given to us here. Times what? Times 4.2 times what? Times the temperature change. That means it will not be 312 minus 298. It will not be what? 312 minus what? 218. So it will now give me what? Over minus what? Sorry. 312 minus 298. Now what do you have there? You have what? You have 14. Now, if you look at this, therefore, your answer will now be what? 100 times, we have 100 times 4.2. That will give me 4,420 times what? Times 14. That will give me what? 5880. Now, this is the heat that 0.02 moles of ethanol was able to produce. Therefore, look at what will now happen. If that is the heat in joules, therefore 0.02 produce this amount of heat, 5880. Therefore 1 mole of ethanol will now produce what? X. Show you the same. So because they are asking us for the combustion of ethanol, but this is the number of mole, or this is the heat generated by these grams, we should convert it to what? To moles. Now, if you do that, what will now happen? Cross multiply. X will now be equals to 5880 divided by what? 0.02. Now, we are going to be having what? Divided by 0.02. So we'll be having what? 294,000. That means we'll be having what? 294 kilowatts kilojoule. Now that is our what? That is our answer. So ladies and gentlemen, these and other questions, remember, you should not forget when you are solving this kind of question, you should not forget what data A stands for, what data S stand for, and what data G stand for. Of course, you know this is enthalpy change. Entropy change gives free energy, and of course you must know what they mean. Let me quickly give you a quick breakdown so that you understand these things properly. Now, this is enthalpy change or the heat content. If it's positive, that means it's an endothermic reaction. It's an endothermic. Like this one is positive, is an endothermic. If it's negative, it's an exothermic. What's exothermic reaction? Reaction in which heat is what liberated, but endo means heat is what absorbed. Now, entropy change, degree of disorderliness. For example, we want to compare water and steam. Which one of them is more disorder? The steam, obviously. So steam, we have a higher entropy value when compared to what water. Now, this delta G is energy available to perform work in a chemical reaction. So you get. Now, if delta G is negative, that means reaction will occur spontaneously. Now, when a reaction occurs spontaneously, it means that the reaction occurs on its own without external factors, maybe peradventure without a catalyst. Sure, you get them now. So you must know all these terminologies. So I'm going to bring in out questions like this and other questions. So please, if you know that you have a topic that you want me to try, just drop it in the comment section. And of course, if this video has been of use to you, of course, put your comment in the comment section so we get to trash these videos and other videos. I'll see you in the other video. Major is out of here. Thank you.